buoyant force per unit volume. This is why load line marks include different references for different water conditions. The same displacement principle still applies. Buoyant force equals the weight of displaced fluid. Change the fluid density and the amount of volume needed changes. Temperature also has a smaller effect because warmer water is usually slightly less dense than colder water. These details remind us that floating is a physical balance, not a fixed property of the ship alone. The ship interacts with whatever water it is in. A vessel loaded safely for one condition still needs to respect another. Seawater's density is part of why ocean shipping works as it does, but it is not enough by itself. A badly overloaded ship can sink in seawater. A properly designed ship can float in fresh water if loaded within limits. The important point is that the environment contributes to the balance. The hull pushes water aside, and the water's density determines how heavy that displaced volume is. This is also why people float differently in salt water than in a swimming pool, and why objects can behave differently in different liquids. Buoyancy is not just about the object. It is about the object and the fluid together. A steel ship is impressive partly because it operates in a medium that is dense enough to support enormous loads, but only when the vessel gives the water enough volume to push against. Floating at the dock is only the beginning. A ship at sea is constantly moving through a changing surface. Waves lift one part of the hull and drop another. Wind pushes against the sides and stacked cargo. Turning creates sideways forces. Speed changes how water flows around the bow, hull, rudder, and propeller. The ship is still supported by buoyancy, but the support is not perfectly even from moment to moment. In waves, the underwater volume changes locally as the hull rises, falls, and pitches. A vessel may slam into waves, bury its bow, or roll as the sea approaches from the side. Designers have to consider reserve buoyancy, freeboard, stability, structural strength, and